see if I can make this bigger. But if we want to calculate these two probabilities, the first one is the probability that a randomly selected subject has a length greater than 164. I just made up a probability. Oops, where'd it go? Yeah. So here's my length variable. I want to calculate the probability that a randomly selected subject has a length greater than 164. So one way of doing that is you could sort your data set from least to greatest on this column, and then just count or use here. I'll just do it for you. Let's sort it from least to greatest. Find out where 164 is. So it said greater than 164, so that means 165 or larger. So it starts on row 39, and then all these up until 133 are have lengths greater than 134. So 133 minus, where did I start? I forgot. 139, then plus 1. So that's 95. That means there's 95 people that meet this condition. So with probabilities, what you do is you find out the number of people that meet your condition and then divide it by the total number of people in your study. Okay. So it starts on row 1, we go all the way to row 133, and then this is a missing value, so we'll exclude that. So that means there's 133 people in this study. That's what goes on bottom. Because a probability is an amount you're interested in divided by a total. There's 95 people that have a length greater than 164 out of a total of 133 people. So 95 divided by 133, that's our probability, approximately 0.714. I use squiggly equals to show that I cut off my decimal. Now this one looks similar, but it's a slightly different calculation. Calculate the probability that a randomly selected subject has a length greater than 164. Same thing, but given that they are a current smoker. So that means we're only considering smokers. There's a couple of different ways of calculating this probability too. But here's what I would do. I would sort the data set from based on their status as smoking. So here's current smokers. That's the criteria we're supposed to have. So we're only considering the total this time is 17. So we're going to divide by 17 in the end. And since this is a small amount of numbers, we could manually count how many of these are bigger than 164. I think it's already sorted too, so that makes it easier. Look, it starts on 166 because of our previous sorting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12. So there's 12 out of 17 that were a previous smoker. So that's 0. It's about the same probability. So it looks like being a smoker is, it looks like the height or whatever this number is independent of whether they are currently a smoker or not. Because the probabilities are the same whether you calculate it over all the types of smokers, like current, former, or non-smokers. The probability is the same if you calculate if they are currently smokers, only those people. You would say there's some sort of impact, like maybe here. Let's say this is actually 16 out of 17. Probability is higher. What that means is being a smoker seems to imply that you have a higher probability of being greater than 164 than not being a smoker, because only smokers had a higher probability for this condition of having a height greater than 164, right? Compare those two. So the smoker group has a higher probability. And later on statistics, you can test to see whether that's big enough to say, yes, that's statistically significant or not. But the other way of doing that, if you're having trouble for some reason, is you can quickly have Excel count how many people meet this criteria. So we've got current smokers just like we want. Let's say this wasn't sorted the way we wanted. This is all jumbled up. You can quickly make a column of ones and zeros where the ones represent a person that has a length greater than 164. So get an empty cell next to this column that we're sorting based on. Type equals if, and we want to check to see whether this cell C2 is greater than 164. And if it is, we put a 1. If it's not, we put a 0. So look how I put those commas. If C2 is greater than 164, we're going to make this column be a 1. And if it's not, it's going to be a 0. And it did that correctly. 158 is not greater than 64, so put a 0. So I clicked and dragged just like I've done with a lot of other videos. Oh, what's wrong here though? That's greater than 164. Why did that one not work? Oh, it's off by one. I said C2. I should have said C1 up here. Sorry about that. So click and drag. There we go. Okay. And then now you can just quickly sum up this column. Equals sum. So type equals sum G1 colon, then where do we end? G17. So that added up the column. That's that 12 that we counted manually, right? So if you have a ton of different values and they're not sorted where you can easily hand count them, then you can use that trick where you can make a column of zeros and ones to meet your criteria and then sum that column. So there's 12 people that are current smokers and that have a length greater than 164. You can do the same thing if it's words over here. For this conditional, let's say we wanted to count, do I have another variable? Yeah, if they're women. So if B1, that's my column that has the word women and men, you can check to see if it is a certain word. If B1 equals women, check the case on that though. Yeah, it's all lowercase. If it's women, put a 1. If it's not, put a 0. And then click and drag that formula, and that just counted up ones and zeros, ones being women, zeros being men. So there was 8 women out of all the current smokers.